Audio Jungle.
Today, we are going to look into an important chapter in geography, that is global atmospheric pressure belts and planetary winds. I hope everyone is safe at home, and stay safe. Let us go into a chapter. Let us connect the knowledge we have gained from our previous classes first. So, what is an atmospheric pressure? We all know our atmosphere is composed of water vapor, dust particles, and gases. All these elements have their own weight. If these factors are combined, we will get a large blanket of air, what we call the atmosphere. This atmosphere exerts a sort of pressure over the body of Earth through its weight. It is called the atmospheric pressure, and the prime factor which attracts this pressure to the Earth's surface is the gravitational pull of the Earth. Now, let us look into some of the technical terms associated with atmospheric pressure. The SI unit of atmospheric pressure is hectopascal, and its alternative in metric system is millibars. The average atmospheric pressure at sea level is 1013.25 MB of the millibars. Children, these two facts are primarily important for your exams and you need to study it well. The main instrument used to measure atmospheric pressure is mercury barometer or simply barometer. We need to have a clear understanding of relationship between temperature, humidity and pressure of air. If the temperature of an air body increases, correspondingly it becomes warm and ascends, as a result of which a low pressure is created. Similarly, if temperature is low, the pressure will be so high. Humidity is the amount of water vapor present in the atmosphere, and water evaporation increases as the temperature increases. Similarly, there also exists an inverse relation between air pressure and humidity. Now, let us look what is a wind. The global pressure is not uniform, hence there are variations, as a result of which air moves from regions of high pressure to low pressure horizontally. It is called the wind. The speed and direction of the wind is controlled by three factors: the pressure gradient, Coriolis force, and the friction exerted by the Earth's surface. So, first of all, we will look into what is pressure gradient. Pressure gradient is simply the pressure difference between two places horizontally, and if the pressure gradient increases, the wind moves faster, and if it decreases, the velocity of the wind decreases. Coriolis force is a universal force which controls the direction of a moving object over the Earth's surface. As the Earth rotates from west to east direction, then the surrounding moving body deflects from its original path. That is, in northern hemisphere, the deflection is towards right, and in southern hemisphere, towards left. This particular movement is explained in terms of wind in Ferrel's law. Friction. The ocean and plain areas have a uniform flat surface compared to land areas. As a result, wind moves relatively in a higher velocity in oceans and plains compared to other regions. Now we can go into our main topic, that is the pressure belts. On our Earth's surface, atmospheric pressure is not distributed uniformly. There are global variations induced by thermal factors of temperature and dynamic factors of pressure. Hence, it is divided into separate pressure regimes having uniform characteristics. It is called the global pressure belts. On Earth's surface, there are 7 pressure belts, that is, an equatorial low, 2 subtropical highs, each in southern and northern hemisphere, 2 subpolar lows, that's 2 in northern and southern hemisphere, and 2 polar high pressure belts. These are the 7 global pressure belts. Now let us look into each of these. Equatorial low pressure belt, which is found between 5 degree north and 5 degree southern latitudes. The pressure belt is the equatorial bulge of the earth where we receive our maximum insolation and the corresponding intense convection takes place and air moves up as convectional currents. Hence, a low pressure belt is created here and only feeble winds called doldrums are present in this region. The subtropical high pressure belt. The high pressure belt lying between 30 to 35 degree northern and southern hemisphere. The air which moves up from the equatorial low after undergoing condensation, the rest of the air moves towards the subtropical areas through the upper atmosphere and gets deposited here, as a result of which a subtropical high pressure is created out here. It is also called as horse latitudes because the water in such a stable condition, the wind movement will be extremely slow, and the ship passing through these oceans of subtropicals had to throw out hoses from their ships for easy movement. The subpolar low pressure belt, found between 60 to 65 degree northern and southern latitudes, is formed due to the throwing out of the air from this region by intense Coriolis force. And the last and final belt, that is the polar high pressure belt formed around northern and southern poles. This is a dynamically induced pressure belt. The regions which receive the least insulation and the air thrown out from the subpolar lows descends here, and the air is swirled into high pressure caps around northern and southern hemisphere, and as a result of which the 2 high pressure belt is formed around the northern and southern poles. Thus, there are 7 global pressure belts around the Earth's surface. We have studied it, and now we can go into the next topic, that is the planetary winds. Now, let us look what are planetary winds. We have studied the global pressure variations in terms of pressure belts. Since the air moves as winds from high pressure to low pressure and created with the presence of global pressure belts, there will be global large-scale air movements, and these are called the planetary winds. We can just glimpse through which are these planetary winds. The trade winds. The planetary winds moving from subtropical highs to equatorial lows. Due to the Coriolis force, it moves from northeastern direction to southeastern direction in northern hemisphere, called the northeast trade winds, and from southeast to northwest in southern hemisphere, called the southeast trade winds. Westerlies. The planetary winds from subtropical highs to subpolar lows, called the westerlies, since it moves from southwest and northwest, commonly the west direction from both hemispheres, it is called the westerlies. The polar easterlies. The uppermost cold planetary winds or the polar easterlies moves from polar highs to subpolar lows, that is from northeast to southwest in northern hemisphere and southeast to northwest in southern hemisphere. Children, in this picture we can clearly see the above mentioned global pressure belts and the corresponding planetary winds formed between them. Just have a look into it. We can see the equatorial low pressure belt, subtropical high pressure belt, subpolar low pressure belt, and the polar high pressure belt around the north poles and the south poles, and the planetary winds formed as a result of these variations in the form of trade winds, westerlies, and the polar easterlies. In this video, children, you will be able to see the direction of the planetary winds created out in the Earth's surface due to the variations in the global pressure belts. I hope everyone enjoyed today's session. You have to do some map work and assignments and also attend the quiz. Stay home and stay safe, my dear children. See you in the next class.